Okay, so we're going to be solving the equation, the square root of the sum of 5x plus 39 is equal to x plus 3. So to solve this one, notice we have one radical this time. So we're going to use the one radical approach. To do the one radical approach, we want to make sure everything outside the radical is on the other side. Notice nothing is outside the radical. So everything is on the other side already. So we're going to start by getting rid of the radical. And to do that, we shall square both sides. Squaring and square rooting cancel out, leaving us with 5x plus 39. On the other side, remember, you can't just square both terms like we did on one of the other problems because they're connected by addition and subtraction. Exponent properties don't work if it's connected by addition and subtraction, so we have to do this a different way. There is a formula that you can memorize for distributing a binomial squared. If you have a hard time with it, you can always remember that x plus 3 squared means x plus 3 times x plus 3, and then distribute it out like that. No matter which way you distribute it out, you should get x squared plus 6x plus 9. After simplifying the perfect square there, we go on to solve the equation. So we no longer have a radical, so we have to solve this resulting equation. Based on the exponent, I would say it's a quadratic equation. So I'm going to move everything to one side. I'll subtract 5x from both sides. I'm going to subtract 39 as well from both sides. Everything on the left side is going to cancel, leaving us 0 equals x squared. 6x minus 5x is 1x, positive 1x, or just x. And then 9 minus 39 is negative 30. So this is a quadratic equation, so we're going to factor to solve this equation. You could also use quadratic formula. I just find factoring quicker. So I'm going to multiply first and last. That's the approach I use for factoring. Gives me negative 30 x squared. Different ways we can factor negative 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. We're looking for the combination that multiplies to be negative 30 but adds to be positive 1. The combination we're going to need is 5 and 6, with the 5 being negative. Since there is no leading coefficient, we can jump straight to the factors without doing factoring by grouping. So jumping straight to the factors, we're going to have our factors being x minus 5 and x plus 6, and we're still set equal to 0. So we're not quite done. We still have to finish solving the equation. So going through, zero product property means we're going to set each factor individually equal to 0, then solve. So we're going to add 5. So x is 5. Subtract 6 on both sides. So x is negative 6. Now do remember with radical equations, you want to solve check your solutions in one way or another. It doesn't really matter. I'm just going to check it by hand this time since they are whole numbers. So just checking our solution here by hand is the square root, checking the 5 first. 5 times 5 plus 39, is that equal to 5 plus 3? That's my check off to the side. So 5 times 5 is 25, plus 39, 25 plus 39, 50, 64. Is the square root of 64 equal to 5 plus 3, which is 8? Yes, it is. So 5 is indeed an answer. We just have to check the other one now. So the other one was negative 6. That was not circled very well. There we go. Let's try the negative 6 now. So we got 5 times negative 6 if we plug it into the original equation, plus 39. Is that equal to negative 6 plus 3? Well, 5 times negative 6 is negative 30, plus 9, or 39, which is 9, square root of 9, that is. And on the other side, we have negative 3 plus or negative 6 plus 3, which is negative 3 overall. Square root of 9 is not equal to negative 3. So this second solution isn't actually a solution for the original problem. It's what's called extraneous. And don't count my spelling for that because I'm terrible. But it's an extraneous solution, so it's a solution that works out algebraically but doesn't solve the original question. So the only actual solution we have is 5.